Hello, this is Module 1, Lesson 8. We are representing proportional relationships with equations. So write down your essential question. How can unit rate be used to write an equation relating two variables that are proportional? Okay, you can go ahead and pause it and write that down if you need to. Otherwise, we're going to go ahead and get started. Okay, example 1 says, your mother has accelerated onto the interstate, beginning a long road trip, and you notice the low fuel light is on, indicating that there is half a gallon left in the gas tank. The nearest gas station is 26 miles away. Your mother keeps a log where she records the mileage and the number of gallons purchased each time, every time she fills up the tank. Use the information in the table below to determine whether you will make it to the gas station before the gas runs out. Okay, so when I uncover this, we're going to talk about what this means. X is going to be the gallons. It is independent because you determine how much gas you put in. The miles driven is dependent on the amount of gas you have. Okay, let me put that into words that make sense to you. If you put in 8 gallons of gas, that determines how many miles you can drive. You can ask your parents about that. Okay, so however many gallons you put in, it determines how many miles you can drive. Now, it fluctuates sometimes, but we can use our gas tank's previous patterns to predict using like an average. So it looks like here that if you put in 8 gallons, you'll be able to drive 224 miles. If you put in 10 gallons, you'll be able to drive 280 miles. And if you put in 4 gallons, you'll be able to drive 112. Okay, let's find the constant of proportionality and explain what it represents in this situation. Okay, we know that the constant of proportionality is found by doing y over x. Okay, so the more we write that, the more you're going to know. That's going to be our go-to. So y over x. We're going to go ahead and prove it with all 3 of those examples. If y is 224, that goes on top, and x is 8, that goes on bottom. Okay, then we can look at the next one. It would be 280 over 10. And for the last one, it would be 112 over 4. Okay, I want you to actually pause this and go ahead and solve them and see what you get every time. Okay, did you get 28? So we know that it is proportional, and that means that you can go 28 miles for every gallon. That's the unit rate. Okay, let's go ahead and write that equation, okay? So we know that our equation is going to look like y equals kx. Y equals kx. Okay, so y is going to be the miles driven. So just to write this out in words, miles driven equals k, which we found, right? Y over x is equal to k. That's the unit rate, the constant of proportionality, the magic number. It's that special number that we keep trying to get to every time. So that's 28 times the gallons. So that's what it means in words. If we multiply 28 times the gallons, that will give us how many miles we can drive. Okay, so what if there is half a gallon left in the gas tank when the light comes on? Will she make it to the nearest gas station? Okay, well, they tell us that the gas station is 26 miles away. So that was way back at the beginning. The nearest gas station is 26 miles away. Okay, so will she make it? Will she make it? Well, here's one way to think about it. Let's put this here. If 1 gallon is 28 miles, then half a gallon, how far could I go with half a gallon? I want you to try to fill that in. How far could you go with half a gallon? Okay, 1 gallon is 28 miles, so half a gallon would be half of that, 14 miles. So do I have enough? No, because I can only go 14 miles. Okay, now let's use the equation and determine how far we can go on 18 gallons. Okay, so we're going to use the equation, and actually I apologize, let's write the equation in numbers here, y equals 28x. And the reason we know that that works, that y equals 28x, is because if we go back up here, 28 times 8, the x, gives me 224, the y. Again, 28 times 10 gives me 280. So anytime I multiply 28 times the x, I'll get the y. Okay, so just so you know that. In fact, let's box that. Okay, so now we're going to use that equation to determine how far we can go on 18 gallons. Okay, we're going to solve it two ways. We're going to use the constant of proportionality and we're going to use an equation. Well, I just got done talking about the equation, so let's actually write that down. Okay, so y equals 28 times. What is 18 gallons? Is that x or y? X or y? Go back up to your table if you need to know. It is the x. Okay, good. So we're going to actually plug that in right here. 28 times 18. Okay, and then when we multiply that, go ahead, pause it if you need to. Did you get 504 miles? Okay, and then you could keep going with that table, right? So if you know that, let's say, if the x is 1 gallon, we already figured that out. We can go 28 miles. And then using some more from up above, 10 gallons would be 280 miles. Okay, so now let's plug in 18 gallons. Okay, you're using that same constant of proportionality, and you would get 504. So that's another way to show it. They're really the same method, though, because we multiplied by 28 for each. Okay, now for this one, using the constant of proportionality and then using the equation, determine how many gallons of gas would be needed to travel 750 miles. So be careful. This one, is this x or y, and how do you know? It is the y. Very good. It's the y because the y is the miles. So let's go ahead and make like a little mini table again for that constant of proportionality. Okay, so we already know from up above that if x is 1, y is 28. If x is 10, y is 280. Now for this one, we're going to put 750 in for the y. So how can you figure that out? How can you figure out what the x would be? You know that it needs to equal 28 if I divide y by x, so we can do 750 divided by 28. Okay, and that's about 27 gallons. It should be a decimal. You should have gotten something like 26.78, so on and so forth. Okay, so about 27 gallons. Okay, we're going to use the same equation, but this time, instead of filling in the x, we're going to fill in the y. The y is 750, and that equals 28x. Okay, now we have to divide both sides by 28 to get what x is. And that's the exact same thing we did over on the other side, and it's 26.785. You don't have to keep writing everything. That equals how many gallons? So approximately 27 gallons. Okay, a lot of kids are asking how we know which one is which when it comes to x and y. So just keep in mind that the gallons determines how many miles we can go. Okay, so if I have 1 gallon, I can go this many miles. If I have 2 gallons, I can go this many miles. Okay, and that's how we kind of come up with that line when we graph. So just a little visual for you there. Okay, we have one more example about Andrea's portraits. That's example 2 on page 29. She's a street artist in New Orleans, and she draws caricatures, which are cartoon-like portraits of tourists. I bet you've seen this somewhere, even if you haven't been in New Orleans. That's all around where you see people, making those cartoon things like at amusement parks or, somewhere touristy. And you can have your portrait drawn and then come back later to pick it up. So it shows here how much time she spends and how many portraits are drawn. Okay, so on that graph, they kind of give us a line, but they don't really tell us, any more information. We have to be able to read this graph in order to know what it's talking about. So try to figure out where it crosses neatly. Okay, in other words, where can you see clearly two numbers? Okay, did you see that there was a spot right here when the time is 2 and the drawings is 3? So I'm trying to get it right exactly on there. Okay, and then this doesn't go clearly, this doesn't go clearly. Oh, right here, this looks pretty clear. 6 portraits would take 4 hours. Does it say hours? Yes, it does. Okay, good. It just said time on the graph, so put hours. Because, you know, it's not going to take minutes or days, but we still want to know for sure. Okay, and then it looks like the last one that we can see clearly is right here. So 9 portraits would take 6 hours. Okay, so we're going to try to figure out how many portraits she can draw or how long it will take. So we're going to write several ordered pairs from this. Okay, ordered pairs. Remember, ordered pairs have X first, then Y. Okay, so that first ordered pair, X is on the bottom, 2 hours. I can make 3 portraits, or Andrea can make 3 portraits, not me. Okay, and then 4 hours to make 6 portraits, and 6 hours to make 9 portraits. Is that proportional? Without doing the math, can you tell on this graph if it's proportional? You should have said yes, because it obviously goes through the origin and it's a straight line. Okay, now what we're going to do is we're going to actually figure out what the equation would look like. Okay, in order to figure out the equation, we know that we can do y over x. And look how nice and neat this is. We already have it in terms of x and y, so we just put the y first and the x on the bottom. Go ahead and pause this and see what happens. Since we know it's proportional, we should be getting the same number every time. Go ahead and see if it works. Okay, did you get 1.5 for each one? That is our constant of proportionality, our unit rate, and what it means is that I can make 1.5 portraits per hour. Okay, so we're going to go ahead and write that as an equation, and it's going to look like this. Y equals 1.5x, where x is the hours, and y is the number of portraits. So however many hours I have, I can multiply that by 1.5, and that will tell me how many portraits I can make. Okay, so actually let's go ahead and write this together. Determine the constant of proportionality. Let's write that the COP equals 1.5, which means (1.5) times the number of hours tells me how many portraits I can make, or Andrea can make. Okay, you don't have to write the part in red if you don't want to, because it just kind of goes on to reiterate that. Okay, now the summary, just like all summaries, you can go do that now, or you can do it in class if you have questions on it, but you're just answering that essential question. So how can unit rate be used to write an equation relating to variables that are proportional? So all you're going to do is put into words, how did we take the unit rate and make it into an equation? Okay, and that is going to be a wrap on lesson 8.